I'm Shae Skager. This is my informative speech. This is my audience. The 1998 Hollywood movie, Armageddon, depicted a giant asteroid on a collision course with Earth. Many people think this is a crazy notion, but plenty of people believe that this could happen. In fact, some thought that on December 21st, 2012, just such an asteroid was going to smash into Earth and kill everyone. Scientists, of course, knew this wouldn't happen. They know where large space rocks are located, when they will appear, and how close they'll be to our planet. It may seem to be the stuff of science fiction or a big-budget disaster movie, but flying space rocks are a reality. They could pose problems for us in the future, but they could also be a goldmine of knowledge, resources, and wealth. Today, I will describe asteroids and comets and talk about what makes them different. I will also define the difference between meteoroids, meteors, and meteorites, and describe meteor showers. And finally, I'll detail what scientists are doing to study all these leftover planetary pieces. According to NationalGeographic.com, asteroids are rocky, airless worlds that orbit our sun and measure in size from a few feet to several miles in diameter. Many believe a gigantic asteroid slammed into the Earth about 65 million years ago and killed off the dinosaurs. According to UniverseToday.com, the impact crater possibly produced by this asteroid is called the Chicxulub crater. It lies mostly underwater and is buried beneath the Yucatan Peninsula in Mexico. The crater is 105 miles in diameter and likely caused tsunamis, earthquakes, and volcanic eruptions around the world. The United States is also home to a very large impact crater, Beringer Crater, near Flagstaff, Arizona. This crater is about 500 feet deep and was likely formed about 50,000 years ago. The closest that a recorded asteroid has ever come to Earth was within 3,400 miles. The asteroid, though, which performed its flyby in February 2011, was only about 3 feet in diameter. It is sometimes difficult to distinguish an asteroid from a comet. Both asteroids and comets orbit the sun and can be similar in construction, but asteroids lack a coma, which is a fuzzy outline and visible tail that surrounds the comet. NASA defines comets as balls of ice, gas, rock, and dust, sometimes calling them large, dirty snowballs. When a comet's orbit brings it close to the sun, it heats up, and dust and gas are expelled, revealing the magnificent tail, which sometimes stretches for millions of miles. Perhaps one of the most famous comets in recent history was Hale-Bopp, which passed through Earth's atmosphere in 1997 and was visible to the naked eye for 19 months. This is the longest any recorded comet has been visible. And then there are meteoroids, meteors, and meteorites. Have you ever doused yourself in bug spray, piled a couple blankets on the ground in your backyard, and lay down to peer up at the stars, hoping to see a flying flash of fire barreling through the sky? If so, then you probably know about meteors. A meteor has 3 stages. First, it's called a meteoroid, when it's a rock flying around in space. These rocks are likely chunks that have broken off from an asteroid or comet. They become meteors, or shooting stars, when they fall through Earth's atmosphere and are heated to incandescence, leaving a bright trail behind them. These shooting stars appear to be huge in the night sky, but they're actually quite small. They can vary in size from grains of sand to large boulders, but most are about the size of a golf ball. If the meteor survives the fall from space and hits the ground on Earth, it is called a meteorite. A large group of meteors occurring together is called a meteor shower. Many of these showers occur at the same time each year and allow us to see dozens of meteors per hour. Perhaps the most famous meteor shower is the Perseids, which peaks around August 12th each year. Other famous showers include the Leonids, Geminids, and Lyrids. NASA conducts ongoing studies of asteroids and comets that pass close to Earth, calling them Near-Earth Objects, or NEOs. The NASA Near-Earth Object Observations Program, commonly called SpaceGuard, monitors the NEOs to determine if any could be hazardous to our planet. NASA's funding to continue this research appears to be secure for the moment, President Obama supports ongoing space exploration, in particular, research about NEOs. In April 2010, the president spoke at Kennedy Space Center in Florida and said, "By 2025, we expect new spacecraft designed for long journeys to allow us to begin the first ever crewed missions beyond the moon into deep space. We'll start by sending astronauts to an asteroid for the first time in history." NASA is developing a plan to capture an asteroid and put it into orbit around the moon so astronauts can easily travel there. According to the Keck Asteroid Retrieval Feasibility Study, published April 2, 2012, it would be possible to return a 550-ton asteroid to high lunar orbit by 2025. But why on earth would we want to send an astronaut to an asteroid? Scientists claim there are many reasons. Astronauts could train there. We could learn how to deflect one from a possible collision with Earth. There's even the possibility of people living on an asteroid in space. Perhaps the most intriguing reason to capture and study an asteroid is that they are believed to be rich in minerals and water that could be mined. Planetary scientist John S. Lewis, in his book, Mining the Sky, estimates that the iron, nickel, cobalt, and platinum metals in the Almond asteroid, which is less than 2 miles in diameter, would have a combined market value of $20 trillion. Imagine it, like a real-life version of a Minecraft game. Astronauts and their robotic partners could discover rich ores and minerals and remove these natural resources from the asteroids, allowing the citizens of Earth to cash in on the revenue. With all we know about asteroids, comets, and meteors, there's still more to learn. Astronauts, astronomers, and scientists will continue their research. They'll learn more about the dangers these space rocks pose and the riches they hold. Someday soon, instead of watching a Hollywood blockbuster about a fictional flying rock, we could be watching live coverage of an astronaut bounding across an actual asteroid. Fueled by our imagination and our curiosity, we will continue to use the tools of modern technology and our own human ingenuity to get a better picture of what lies beyond.